Good morning, grade 10 students. Welcome to Valenzuela Facebook Live and another day of new great learnings. In your previous lesson, you have learned electromagnetic radiation is energy that is propagated through free space or through a material medium in the form of electromagnetic waves such as radio waves, visible light, and gamma rays, including the difference between the ionizing and non-ionizing radiation. I am Ma'am Leia from Malinta National High School, your teacher for today. And for today's lesson, we are going to discuss a new lesson in physics entitled Plane Mirrors and Curved Mirrors. The objectives of our lesson are the following. Number 1, identify and define the terms related to reflection of light in plane mirrors. Number 2, distinguish converging and diverging mirrors. Number 3, apply ray diagram technique in describing images formed by mirrors. And number 4, use mirror equations in predicting the characteristics and position of an image formed by mirrors. Let us begin. Let us have the objectives. Have you noticed the word ambulance in an ambulance car? How is it written? Did you ever wonder why is it written that way? We will find the answers on these questions as we go through our lesson. Whenever we look into a mirror or a sound of sunlight glinting from a lake, we are seeing a reflection. When you look at your cell phones or laptops, you are seeing light reflected from it. Even the large telescopes use reflection to form an image of stars and other astronomical objects. Now, let us define what is reflection. Reflection is defined as the bouncing off of light rays when it hits a surface like a plane mirror. The picture on the screen is an example of a plane mirror. What is a mirror? A mirror is a reflective surface that bounces off light, producing either a real image or a virtual image. To understand more about the concepts of reflection, let us have the following important terms that you will encounter while we are discussing this lesson. Incident ray. The ray of light approaching the mirror, represented by an arrow approaching an optical element like mirror. The second one is reflected ray, the ray of light which leaves the mirror and is represented by an arrow pointing away from the mirror. And the next one is the normal line. What is a normal line? This is an imaginary line labeled N that can be drawn perpendicular to the surface of the mirror at the point of incidence where the ray strikes the mirror. This one is a diagram of the law of reflection. In this diagram, the ray of light approaching the mirror is known as the incident ray, labeled as I. The ray of light that leaves the mirror is known as the reflected ray, labeled as R in the diagram. At the point of incidence where the ray strikes the mirror, a line can be drawn perpendicular to the surface of the mirror, and this line is known as the normal line, labeled as N. The normal line divides the angle between the incident ray and the reflected ray into equal angles. The angle between the incident ray and the normal line is known as the angle of reflection. These two angles are labeled with the Greek letter theta, accompanied by a script read as theta I for the angle of incidence and theta for angle of reflection. Another diagram, what you see when you look into a plane mirror is an image which appears to be behind the mirror. This is called virtual image as the light does not go through it. The distance of the image from the mirror is what we call equal to the distance of the object from the mirror. Now, let us differentiate between virtual image and real image. Real image and virtual image are the two classifications of the image that is formed by reflection of refraction of light rays. The crucial difference between the real image and the virtual image is that real images are formed when light rays actually meet at a point after getting reflected or refracted from a mirror, as against virtual images are formed in the case when light rays appear to meet at a point in the vicinity beyond the mirror. This means in the case of the visual image, it is assumed that light rays have met a particular point in the backward region of the surface where the image is getting formed. More simply, we can differentiate the two as the real images can be displayed on the screen, but the visual image can never be displayed on the screen. Let us define what is an image. An image is basically a visual representation of an object which is placed somewhere in front of a mirror. The formation of the image is a result of the meeting of light rays after being reflected or refracted according to the respective laws. Now, these are the characteristics that we will see of the images formed in a plane mirror. Here is the summary. Visual, upright, left-right reverse or laterally inverted, same distance from the mirror as the object distance, and same size as the object. Now let us state the two laws of reflection. Number one, the incident ray, the reflected ray, and the normal to the reflecting surface all lie in the same plane. And number two, the angle of incidence, I, equals the angle of reflection, or R. The reflection of light can be roughly categorized into two types of reflection. The regular, also called as the specular or reflection. It is defined as the light reflection from a smooth at a definite angle, whereas irregular or diffuse reflection is produced by rough surfaces that tend to reflect light in all directions. We are able to see very clear reflection on the smooth surface. Every light ray is reflected perfectly from the surface and bounces back in a regular way. The reflected image is very clear and sharp, and that is what we call a specular reflection. While an irregular reflection or diffuse reflection, when takes place, the light rays are incident on a surface like a wall, the wood, a leaf of a tree, a piece of leather, a piece of paper, or a piece of wood, which are smooth, polished, so the different portions of the surface reflect the incident light rays in different directions. There is no definite image form. It is commonly known as the scattering of light. Another characteristic of a mirror, it is what we call mirror left-right reversal. Why is the word ambulance is spelled backwards on the front of an ambulance? When an ambulance is behind you while driving, you see it through the rear view mirror. In the mirror, the reverse writing looks normal, and you are able to read the word ambulance. Just like the man who is raising his right hand in front of a plane mirror. The left side of the object appears as the right side of the image, and the right side appears as the left. And this effect is known as the mirror left-right reversal. In here, you will see a multiple images. Why are multiple images formed when two mirrors are placed? It is because the images were formed when two mirrors are inclined at an angle and the object is located between the mirrors. Numerous images are formed due to multiple reflections on the mirror. For example, two mirrors are placed at right angles, 90 degrees to each other, will form three images. What if it is 60 degrees, 45 degrees, or 30 degrees? So that's for you to find out. Let us proceed now to spherical mirrors. Did you know that the spoon that we use whenever we eat our food is an example of both concave and convex mirror? Yes, it is. You can try yourself by looking into the concave side of a shiny spoon. If you look into the spoon while holding it at arm's length, you'll see an extremely magnified upside-down image of your face. But as you bring the spoon closer to your eyes, the image will get bigger and bigger. Therefore, the image formed depends on the distance of the object from the focal point of the mirror. There are terminologies in curved mirrors. So for us to understand spherical mirrors, let us review important terminologies. The first one is the principal axis. Principal axis is a straight line drawn through the center of the mirror. The next one is the vertex. It is represented by a letter V. The point where the principal axis meet the mirror. Next one is the focal point. It is represented by a letter F, where all reflected light rays converge. The next one is focal length. It is represented by a small f, the distance from F to the mirror. The center of curvature is represented by a capital letter C. It is the center of the sphere to which the mirror belongs. And the last one is the radius of curvature, represented by a big letter R, distance from C to the mirror. Now, let us label the parts of a curved mirror. The principal axis, the focal point, the focal length, the center of the curvature, curved mirrors. Now, there are two types of curved mirrors. The first one is a concave mirror. Concave mirror. It is also called a converging diagram. Concave mirror reflect light inward to one focal point. These mirrors are called converging mirrors because they tend to collect light that falls on them, refocusing parallel incoming rays towards a focus. It is also called a converging mirror because the parallel incident rays converge or intersect at the focal point after reflection. The next one is a convex mirror. It is a curved mirror in which the reflective surface bulges towards the light source. It is a diverging mirror. A convex mirror is a diverging because the parallel incident rays diverge after reflection. When extending the reflected rays behind the mirror, the rays converge at the focus behind the mirror. Let us now do this activity number 1. Applications of curved mirrors, identifying the following pictures if it is a concave mirror or convex mirror. The first one is a side mirror of a car. You will be given 5 seconds to answer. Time starts now. You may now write your answer at the comment box. Let us begin. Alright, time's up. The correct answer is the side mirror of a car is a convex mirror. It gives a wide field of view of the traffic behind the vehicle. The next picture is a make-up mirror. So what is it? Is it a concave or a convex? In 5 seconds, go. Time's up. The correct answer is, it is a concave mirror. Since concave mirror focus light and magnify the object, it allows you to see your face in more detail. Next one is a surveillance mirror. You will find it in a 7-Eleven or supermarket. So what is it? Is it a concave or a convex mirror? Time starts now. Time's up. The correct answer is a convex mirror. Why? Because it reflects a wider field of view than a standard flat mirror. And the last one is a microscope. In 5 seconds, go. Time's up. A microscope, usually concave mirror, used in all the microscopes. The combination of lenses and mirrors used in making the microscope helps in obtaining magnified and sharp image of the objects. Great job, students. Thank you for your participation. Next one. Images formed by a curved mirrors. Do they have the same characteristics as of the plane mirrors? In locating the image formed in curved mirrors graphically, 3 important points are considered. Number 1, the center of curvature, the center of the sphere of which the mirror is part. Number 2 is the vertex, the center of the mirror. Number 3 is the focal point, focus, the point between the center of the curvature and vertex. Its distance from the mirror is known as the focal length. What is a ray diagram? Images formed in curved mirror can be located and described through ray diagram. Ray diagram is defined as the representation of the paths taken by the light when the light is passed through one point to the other. In determining the position and nature of the image graphically, there are 4 principal rays that are used. Ray diagramming is used in the graphical method of locating the image. The first one is the PF ray. PF ray, a ray of light parallel to the principal axis, is reflected passing through the principal focus F. The second one is the FP ray. The ray of light passing through the focus F is reflected parallel to the principal axis. The third one is the CC ray. The ray of light passing through the center of the curvature, C reflects back along its own path. And the fourth one is the V ray. The V ray, a ray of light directed to the vertex, reflects at equal angle from the principal axis. The next one is a convex mirror. Now, this is the V ray. A ray of light directed vertex reflects at equal angle from principal axis. Let us now draw a ray diagram. What if the object, and where is the location, where is the orientation, the size, and the type of image? Follow the rules that we discussed later. So here, the ray of light passing through the principal axis, the second ray of light, the reflected rays, and what is the location of the image? The location is between C and F. The orientation is inverted. The size is reduced. And the type of image is real. Let us answer activity number 2, entitled, Are You Lost? After reflection, so you will construct a ray diagram to determine the location, orientation, size, and type of images formed by a curved mirror. You will be given 15 seconds to answer it. Are you ready? Time starts now. Time's up. What is the location of the image? Let us see. Let us draw first a ray diagram. So here are the arrows representing the parallel light rays and also the reflected rays. The image will fall here. And the location is at C. The orientation is inverted. The size is the same. And the type of image is real. The next one is the location of the object is between C and F. Try to locate where the image will be formed. 15 seconds. Time starts now. Time's up. Let us answer it. Let us draw the ray diagrams, the parallel rays. The image will form. Let us see the location. It is beyond C. Orientation is inverted. The size is enlarged. And the type of image is real. Now, let us have the convex ray diagram. How to draw the steps for drawing in convex mirror. So using rule number 1, draw an incident ray line from the top of the object parallel to the principal axis to the surface of the mirror. Then draw reflected ray line from the surface of the mirror as if it is originating from the focal point. Using rule number 2, draw an incident ray line from the top of the object towards the focal point to the surface of the mirror. Then draw the reflected ray line from the surface of the mirror, parallel to the principal axis. And then use dashed lines, extend the reflected ray lines backwards until they intersect. There is the image. The location is between F and D. Orientation is upright. Size is reduced, and the type of image is virtual. Here is a summary of the location, orientation, size, and type of image formed in curved mirrors, where you can follow and review. Anyway, you can also research this table in the Google or any physics reference book. Ray diagrams provide useful information about object or image relationships, yet fail to provide the information in a quantitative form. While a ray diagram may help one determine the approximate location and size of the image, it will not provide numerical information about image distance and object size. To obtain this type of numerical information, it is necessary to use the mirror equation and the magnification. The mirror equation expresses the quantitative relationship between the object distance, it is represented by DO, the image distance or DI, and the focal length F. The equation is stated as follows. 1 over F is equals to 1 over DO plus 1 over DI. F stands for the focal length or distance from the mirror and the focal point. Another one is P or DI is represented by a distance of the object from the mirror. And the last one is Q, the distance of the mirror from the mirror. The next one is the magnification equation. Relates the ratio of the image distance and the object distance to the ratio of the image height, and the object height the magnification equation is stated as follows. M is equals to HI over HO is equals to negative DI over DO. These two equations can be combined to yield information about the image distance and image height if the object distance, object height, and focal length are known. Now, let us have the sign conventions for mirror. According to it, object is always placed to the left of mirror. All distances are measured from the pole of the mirror. Distances measured in the direction of the incident ray are positive, and thus distances measured in the direction opposite to that of the incident rays are negative. F is positive if the mirror is a concave mirror. F is negative if the mirror is convex mirror. Q is positive if the image is real and located on the object side of the mirror. Q is negative if the image is visual image and located behind the mirror. Height or age is positive if the image is an upright image. Height or age is negative if the image is an inverted image. Let us answer the problem solving number 1. As demonstration of the effectiveness of mirror equation and magnification equation, consider the following example problem and its solution. A 5 cm tall light bulb is placed at a distance of 45 cm from a concave mirror having a focal length of 10.5 cm. Let us determine the image, the distance, and the image size. Like all problems in physics, begin by identification of the known information. Next, identify the unknown quantities that you wish to solve for. So, these are height of the object is equals to 5 cm. The distance of the object is 45 cm. And the focal point is 10.5 cm. Find the distance of the image and the height of the image. So using the formula of the mirror, which is 1 over F is equals to 1 over DO plus 1 over DI, let us solve and use the following formula. The first one that you have to do is to substitute the value. So let us substitute the 1 over F is 1 over 10.5 cm is equals to 1 over DO or 1 over 45.0 cm plus 1 over DI. Next one, the next step is to use the addition property of equality to solve for DI. We will change the sign into negative. So we will get 1 over 10.5 cm minus 1 over 45 cm is equals to 1 over DI. The next step is to a cross multiplication. So we will get 45.0 cm minus 10.5 cm over 10.5 cm times 45 cm is equals to 1 over DI. And then just do simplification. Simplify, then solve. We will get the final answer of DI is 13.7. You can do reciprocal. The next one is finding the magnification or the height. So this is our solution. And the formula is HI over HO is equals to negative DI over DO. HI over 5 cm is equals to negative 13.7 cm over 45.0 cm. And then do cross multiplication, we will get 5 times negative 13.7 cm over 45 cm. And then simplify, solve. We will get final answer, HI is negative 1.52 cm. Problem solving number 2. What is the focal length of a convex mirror that produces an image that appears 15.0 cm behind the mirror when the object is 27.5 cm from the mirror? These are the given. You have the DI negative 15.0 cm. Distance of the object is 27.5 cm. We are looking for F. Determine the focal length The mirror equation will be used. Let's substitute and solve for f. These are the solution. 1 over f is equals to 1 over 27.5 centimeter plus 1 over negative 15.0 centimeter. And then simplify, you will get negative 15.0 centimeter plus 27.5 centimeter over 27.5 centimeter times negative 15.0 centimeter. Then solve. Our final answer is negative 33.0 centimeter. The negative value for focal length confirms that the mirror used is a convex mirror. Now our comment section is now open for your questions. Our teacher moderator will choose 2 questions. You may now comment your questions below. Okay, ready? From Dalandanan National High School, the question is, what happens to the size and location of the image when you bring the flashlight nearer to the concave mirror? Well, when you bring the flashlight near to the concave mirror, the size of the image increases and the location moves farther from the mirror. Conversely, the size of the image decreases and the location becomes farther the observer. The second question is, from Malintan National High School, what type of mirror do dentists usually use to clearly see the images of our teeth, and why? A dentist mirror is a concave mirror because the image appears larger or magnified, making it easier to the dentist to see the details of the teeth. This happens because the object or the teeth is located between the mirror's focal point and the vertex or optical center of the mirror. Other questions will be entertained by your teacher during your class online discussion. Thank you for watching and listening. Have a good day and stay safe, everyone.